Felix Rodriguez. I work at Bleacher Report. Talk's called Docker Rookie of the Year. I do DevOps with them. I've been working at Bleacher Report for about a year now, mostly defining our new infrastructure. And I'm just going to go through a brief overview of kind of how we have everything laid out. So this is how our previous infrastructure looked. I'm sure it looks pretty familiar to most of you. It was mainly Chef to set up all of our configurations and app dependencies. We used CloudFormation to spin up any AWS resources we needed, whether it's Postgres, a Route 53 domain, or load balancers. And then we had Capistrano to kind of orchestrate our deploys. This worked really well. It was hardened, and we had a lot of stacks on production. However, let me do my little, so it worked well, just like, oh, no, it doesn't play over there, that sucks. Well, that's Steph Curry making a 3, Chef Curry. I don't know if you guys seen that GIF yet. But anyway, so it worked really well, and the only problem with it was it took a lot of time, and we had to go directly to ops to build new stacks for us. This was not something that was going to scale, especially when we're moving towards a service-oriented architecture. We looked into different tools, and we decided to give Elastic Beanstalk a shot. At the time, I was doing QA, quality assurance, and I was asked to build a continuous deployment solution. I needed a couple servers to get that done, and ops just didn't have any of the throughput to do that for me. So my boss suggested that I go ahead and spin up some stacks using Elastic Beanstalk. It was very easy. It was like Heroku to kind of get things going. I got a Sinatra app up in like no time. Some of the pros with Elastic Beanstalk we found were we had application versions that were really easy to figure out what was deployed where. There was a command line interface that you could clone existing environments easily, look at logs, SSH into them. It was a very nice GUI for developers to look at their application, see what was there, check the logs if they wanted to, have an event stream. You had rolling deploys, which is something that we didn't currently have in our old infrastructure. We could deploy to one host, then the next host, and the next host, or deploy to 50% of the hosts. And we also had deploy rollbacks, which, if you ever worked in ops, developers push bad code sometimes. Sometimes they don't test it, and they say, oh, specs passed, and throw it up. So being able to roll back quickly is really essential. Also, we had configuration templates. The whole stack was defined in one YAML file, and if you wanted to recreate that one application, it was really simple. And you can also save backups of how the application looked before. EB extensions were also really useful. Think of that as like the chef of Elastic Beanstalk. It allows you to install any other custom additions you needed, like sysdig, which we're going to add one now. Some of the cons, however, were limited solution stacks. When it first came out, you only had Ruby, you had PHP, and you had Node.js. So that didn't quite work out for some of the developers who wanted to build in other languages. So here are some of the solution stacks. If your language was not there, you'd have to build your own custom AMI, and you'd have to use their Elastic Beanstalk base AMI to do that. So you'd have to spin up a new EC2 instance with that AMI, configure it how you wanted, and then make an AMI out of that. Then Docker came out, and Elastic Beanstalk supported a Docker solution stack. Thankfully, we were able to move forward with developing Elixir stacks. We currently have about 5 Elixir engineers. So we're doing both Rails and Elixir, as well as any other experimental languages that anyone wants to code in. This was our first step towards building out our new CMS and programming tools that power all the articles that you see on our site today. This is an example of what that Dockerfile looked like. So basically, we're pulling in an Elixir image. It's installing a couple things that it needs here. It's running some mix commands to compile all the assets it needs, and it's exposing a port and just running Phoenix server. The developers actually built this without any ops help at all. So one of the things that we needed to do now was deploy all the things. Elastic Beanstalk CLI did give you a deploy command, but all it did was take your entire folder and send it to the host. And that didn't really give us a lot of leverage as to doing anything before the deploy or after the deploy, or the deploy kind of builds the image that you sent to it on the fly. What if we wanted to just ship an image that we created somewhere else? So I decided to work on a tool called Gantry. It's an open source tool. You guys can check it out. It's under my GitHub handle. Basically, it allows you to modify the tag you're deploying on the fly. You can create version files that make sense to you. You can have a centralized EB extensions repo. I'll go more into EB extensions now. And this is where you define, on the right, you'll see an example of a Docker run AWS JSON. That's the only file you need to deploy your application to Elastic Beanstalk. And basically, the tag that you're deploying, you would be overriding the master part. So if you built your own branch and you want to deploy that, you would create a new image and overwrite that on the fly with Gantry. Also, we put messages in Slack when we're deploying, so that was nice. That's something you don't get out of the box. This is how you would kind of configure Gantry. It's not much to it. Adding authentication, so we can all use the same Docker Hub token. That way, if we need to, what was that called? I guess kill the token, create a new one, then it's really easy to do so. Extensions, that's where I was saying you could define your centralized EB extensions repo. I'll show you an example in the next slide of what EB extensions look like. The rest of the stuff doesn't really matter so much. Slack for the alerts. Librato is a metrics service. So we send a deploy annotation anytime it happens on any server, so you can correlate metrics with deploys. And then it auto-updates itself and pulls in configuration. One of the EB extensions that we added is creating a Datadog monitor that monitors our Docker containers. So that was one of the first problems we saw with Docker was monitoring. And we looked to Datadog to kind of help us with that. And it does provide a little bit of overview as to what's going on inside the container, but not nearly as much as Sysdig. So some of the things here you'll notice is it's defining a file. And in that file, it's basically just 3 lines, and then it's just restarting the agent. So that's really all you need to create an extension. And that installs it across, because it's a centralized EB extensions repo, any new app that anybody creates on their own, it'll automatically pull this in. So this was really essential for us because our developers were actually building their stacks on their own. And we wanted to make sure we had some control over that. One other thing we wanted to make sure is we automated all of the things. We currently use CircleCI for that because of their native Docker support. We were using Travis, but they don't support Docker directly, so you'd have to use something like Docker Machine to kind of install that for you. It was really easy to troubleshoot because you can rebuild and enable SSH and actually get on the host that was running your build and kind of do whatever you needed to do. They encrypt your environment variables, and it's easy for me to install Gantry and deploy. Here's an example, CircleCI. Basically, on any build, any push that happens, it's going to go ahead and install Ruby, install Docker on this CI machine. It'll set the Docker login credentials needed. We install Gantry. It clones our central config, so that way everybody's deploys look the same. Then we're going ahead and building the Gantry build is the same as Docker build, except for it provides a tagging convention, a tagging name convention. And then we're going to go ahead and run that same container that was built and we're going to run the tests inside of that container. So if you use something like Travis to run your tests and you're working with Docker, you're running that on bare metal, and you're not actually testing your code as if it was running in a container. So that's why we wanted to switch to Circle CI. And then this is how deployment works. So basically, our development workflow is you have your feature branch that you're working on. It gets deployed to a feature stack. So if it's one developer working on a project, he can have his own stack to test his features. Then QA would have their stack for testing the develop branch, which everything gets merged into. Features are pull requests into develop. And then master is when develop looks good, we're going to go ahead and push master out to production. So really simply, with a YAML file, you have continuous deployment using Docker. But then everybody created so many services, and now there's just all these things, and it's all automated. So now our DevOps team's like, oh my God, freaking out. What do we do with all these stacks? We wake up, and there's 3 new projects being built on or worked on, and it kind of makes us a little weary as to what to do next. Some of the challenges with this is service discovery. So right now, we rely on Route 53 domains to kind of link up to each other. So Stag Carburetor App S2 should be talking to Stag DJ App S2, which should be talking to Stag Embedder App S2. So that's how it should be, and it's all defined in environment variables, what host it's looking for. However, that's not always reliable, because with EB extensions, let's say we want to quickly modify our host, we'd want to clone it, and we can't have 2 S2s running at the same time. So controlling which one's talking to which can get really confusing. Centralized logging, something that you don't really get at from EB out of the box. They'll ship you like the last 100 lines of one of your services, but you want kind of everything talking together, shipped to one location. Faster container creation, because EB uses Python scripts and Bash scripts to kind of orchestrate all of its container creation, keeping the container up if it dies for whatever reason, and handling deployments. It takes quite a while to actually spin up a new container. So when you do a deploy, it can take, I've seen it take up to 30 minutes for a new container to spin up, which should be instantaneous. Docker image management, that's something we haven't really figured out quite yet, because everybody's working on their own projects, everybody has their own stacks. How do we kind of centralize how these Docker images are being managed? Is there any kind of conventions we need to be following? We're basically giving developers all of the power. And then cluster replication. So we have a way of spinning up each of these, very codified, very neatly and easily. However, all 3 of them being spun up with one command is not really something we have yet. So something we've been playing around with, possible solutions, is running all of those containers on one host. So currently we're running one container on one host in EB. Though they do support multi-container environments, we think that ECS and Tectonic and Kubernetes, all of these are great solutions. However, I feel like they kind of overcomplicate what we're trying to do at this point in time, and we don't want to add any more layers of confusion for everyone else. So we're looking to something like Rancher, which basically uses all of the built-in Docker-supported API calls, like using Docker Swarm, Docker Machine, and the native Docker commands to kind of build these things. We can spin up all the containers that are required on one host, and there's no need for Mesosphere. It has its own load balancer. It doesn't subscribe us to CoreOS like something like Deis would. Deis, you have to use CoreOS, and you have to spin up like 3 separate servers that act as like a router. So it can get really confusing if you start working with some other workflows. This would be how you would kind of replicate your entire cluster using RancherCompose. Just a heads up, RancherCompose is not actually ready to use, but we're waiting for it to come out, and it currently defines the same way Docker Compose is defined, except for when you run it, it actually throws it on a host instead of running it on your local machine. So you would define, basically this would allow us to have, every developer would have their own host that they can deploy to, and they can test their code and have whatever version of whatever app running inside of there. So this is something we're really looking forward to, and hopefully it should be out soon. Until then, we're using basically the Rancher API native calls to start up these containers. We have each container spun up with its own API call. The first one here, the response will return a ID, and you can use that ID to link the embedder app to the DJ container. So you have your instance links here, and everything else is just environment variables, what ports you want to expose, and the name of it and the image. So it's pretty simple to just spin up a new container with an API call, and it takes just a second. So that's basically my talk, super fast. I just wanted to show you our infrastructure. If you had any ideas that you wanted to share with us into how you can make our infrastructure better, or if you had any questions about how we can make yours better, feel free to hit me up on GitHub or Twitter. That's my username. So that's it.